7.4, Factoring Polynomials, Part 1, or another title would be Factoring out the GCF, the greatest common factor of polynomials. So look at this first question. It says find the GCF of, and you can see this trinomial here, 12x to the 5th plus 8x to the 4th minus 6x cubed. And just to remind you about GCFs, in previous classes you probably just had numbers like this, and you had to find, you had to list the factors of 12, and you start listing all the factors of 12, 1, 2, 3, 4, 6, and 12, the factors of 8, 1, 2, 4, and 8, the factors of 6, 1, 2, 3, and 6, and then you try to find the greatest common factor between those, which is 2. Okay, so 2 would be the greatest common factor between that. And then the same thing with 14, 20, 24. You guys did in previous classes, you did this on several different illustrations, and you would write it out in the factors that way. Another way you could do it is the prime factorization is 2 times 7. The prime factorization of 20 is 2 times 2 times 5. And the prime factorization of 24 is 2 times 2 times 2 times 3. So the prime factorization of those. And then what you can do, so you can see what the only thing that's common between that is a 2. You have a 2, a 2, and a 2. That's the only thing that's common. So the greatest common factor for that would be 2. So there's two ways, depending on how you were taught how to find the GCF. But this is the same idea that we're going to do here. So we have the GCF of 12, 8, and 6, and I just did that so that we know that the answer is 2. Okay, so that's one way we can do it. We can literally just write the answer that we got earlier. Again, another way to do this is if you break it down to primes, prime numbers, the prime factorization 2, 2, 3, and then 8 is 2 times 2 times 2, and 6 is 2 times 3. And then notice what's common between that is you have 2 2's, here you have 3 2's, but here you have 1 2. So what's common with all of those? They all have just 1 2. Well, notice if you do that same thing, if you write x to the 5th, x to the 5th, and so that's x times x times x times x times x, x to the 4th is x times x times x times x, and x cubed is x times x times x. And notice this has 3 x's. I keep using the wrong color, sorry about that. This has 3 x's, this has 3 x's, this has 3 x's. So you're trying to find the GCF, greatest common factor. They all have 1 x, they all have 2 x's, they all have 3 x's, but they don't all have 4, they don't all have 5. So the greatest common would be x cubed. All right, so that's the greatest common factor between all of those. So notice if I wanted to find the GCF of this polynomial, so what I did in your first step is look at all the numbers. So look at 12, 8, and 6. And so that's what I did. I found the greatest common factor between just the numbers, which is 2. And then the second step is look at the variables and find your greatest common factor between that, and that happens to be x cubed. So to answer my question down here, what is the GCF of that trinomial, that polynomial? So it's basically 2x cubed. I basically took the 2 from the numbers, I took the x cubed, and so the greatest common factor is 2x cubed. So now what I want you to do is find and factor out the GCF. So let's first find it, because if you can't find it, then that means you can't factor it. So you have to be able to find it. So our first step is look at the numbers. So look at the numbers between 4 and 6, and what is the greatest common factor between that? So that would be 2, the greatest common factor between 4 and 6. And then look at the factors, look at x cubed and look at x, and what is the greatest common factor between that? Again, what's common between them? This has 3 x's, this has 1 x, so what's common between them is just 1 x. They both have 1 x. All right, so a good way to do this with the variables is always choose the smallest exponent. So that's what we did on the previous problem. So notice we basically chose the smallest exponent, and we know that is common with all of them. So this has 3x's, this has 3x's, this has 3x's. So the smallest exponent is actually the GCF for that. All right, but again, with the numbers, you need to actually find the greatest common factor between 4 and 6, so which is 2. All right, so now we know what the GCF. This is your GCF. Now, what do I mean by factor? Factor is really, it's sort of like the opposite of the distributive property. Think of the distributive property. If I had something like 2 times x plus 4, well, I would multiply that 2, and I would multiply that 2, and I would end up with 2x plus 4. And so it's really the opposite of this. So if you focused on this, notice what's common between those is actually a 2. And so if I basically factored out the common number, a 2, if I factored out the greatest common factor, so factor means division, so it's really going backwards. So if I divided this first one by 2, I would end up with x. And if I divided this one by 2, I would end up with 2. So it's really the opposite of the distributive property to be able to do that. This was supposed to be a 2 right there. All right, so let's look at this. Find and factor out the GCF. So we already know the GCF is 2x. So what we're going to do is we're going to literally divide this first. We're going to divide this by the GCF, and we're going to divide this by the GCF. And what remains is what goes inside that parenthesis. So when I simplify this, what do I get? Well, I get 2x squared. When I simplify this, I get 3. So this is the answer of factoring out the GCF. Notice what I have. This is the GCF right here, and I factored it out. And all of this is your answer. So, and how do you check it? Well, if I did the distributive property, I get 4x cubed, and then I get 6x. Notice that was my original problem. So you can easily check your answer as well by simply using the distributive property. All right, so let's factor out some more. So first you need to find the GCF, and then you need to factor it out. So what is the GCF between here? So first look at all the numbers. So here I have a number 1, I have the number 5, and I have the number 22. So what is the common factor between those? Well, the only common number or factor between all those is 1. Now let's look at the x's. So we have x cubed, x squared, and x. What's common between all those? Remember, for the GCF, you choose the smallest exponent, so it's just an x. So this right here, 1x, that is my GCF. And I'm going to factor that out. So basically, remember what I'm going to do is I'm going to divide the GCF. I'm going to divide this by 1x. I'm going to divide this by 1x. I'm going to divide this by 1x. And what remains goes inside the parenthesis. So this is going to be x squared. This is going to be 5x. And this is going to be 22. So all of this is your answer. Again, including the GCF. And again, I'm going to remind you, how do you double check this? Well, if I double check this by using the distributive property. So x times x squared, that's x cubed. X times 5x, that's 5x squared. And x times 22 is 22x. Notice that is the original problem. It's easy to double check by using the distributive property. All right, let's try this problem right here. We have negative 16y to the 6 plus 18y to the 4 minus 20y cubed. Well, notice, look at the numbers. So I have a negative 16, I have a positive 28, and I have a negative 20. And think of the factors of each of those and the common factors for that. And notice the common factor between those would be a 4. Actually, because this first one is a negative, I'm going to factor out a negative 4. And notice your y's. What's common between all the y's? Well, again, the lowest exponent is going to give it to us. It's y to the third power. They all have 3 y's. So what I'm going to do is I'm going to factor that out. And factor literally means division. So I'm going to literally divide this by the GCF that I have there. So I'm going to divide this by negative 4y cubed, negative 4y cubed, and negative 4y cubed. So again, divide the first one, you're going to get a positive 4y cubed, you're going to get a negative 7y, and you're going to get a positive 5. And as a big hint when you do this, there's inside the parentheses, something I want to make sure, here's another way to double check this. Inside the parentheses, there should not be anything common. If you have something common inside, then that means you didn't factor out the GCF. So if you have, like, for instance, some students, they'll put a Y there. And I'm like, well, I know they made a mistake because you should not have anything common with all three of them. There should not be anything common if you really, truly factored out the GCF. So all of this is your answer. And again, the way to double check that is using the distributive property. And one last problem, again, factor out the GCF. Again, look at all three numbers. So 24, negative 30, and 12, and think of the factors of each one of those. And again, if you need help or practice with those, again, you can always write them over to the side, 24, 30, and 12, and list out the factors, or do it the prime factorization way, 2 times 2 times 2 times 3. 30 would be 2 times 3 times 5. 12 would be 2 times 2 times 3, and you can see what's common between those. They all have 1, 2. Let me get my highlighter out. They all have 1, 2, and they all have 1, 3. So what's common between those is, the GCF is 6. Okay, so 6 is common with all of those. So 6 is there, and then look at your x's. Your smallest amount of x's is x squared, and look at your y's, which your smallest amount of y's is y squared. I'm going to write it down here. And so this is my GCF right here. That right there is my GCF. So if I ask you to find the GCF, that is my GCF. That's all I want to know if I ask you to find it. But if I ask you to factor it, that means I want you to factor that out. I want you to divide each of these terms by 6x squared y squared. And again, you don't have to show the division. You can just do this mentally. Just divide each of them by 6x squared y squared. And so what remains, so let's look at the first one. So if I divide the first one, I'm going to get 4x. Notice the y's cross out. Divide the second one, and I'm going to get 5y. Notice the x's cross out. And then divide the last one, I'm going to get 2y squared. And so I factored each of these out. I have nothing in common with all three of them on the inside of parentheses. And again, one last time, the way to double check this, if I use the distributive property, I can double check this. So that would be 24x cubed y squared minus 30 x squared y cubed, and then plus 12 x squared y to the 4. And notice that happens to be the exact problem I started off with. So I know for sure that this is the factorization. I factored out the GCF. So that whole highlight is my answer. I factored out the polynomial.